Okay, welcome back, Zhamak, for part 2 of your data mesh talk. Let's get started.
Welcome back if you were in my previous session talking about data mesh and introduction to it, and if you're joining for the first time, welcome. This session where I'm going to dive into the foundation of data mesh, what data mesh is really about in terms of architecture, in terms of principles. And I like to kind of introduce the how to build data mesh through its underpinning principles. And the reason for that is how we build in terms of technology and the practices, what tool I use today versus tomorrow, that's going to change. Probably by the time you hear this conversation, that's already changed. So I want to get you to think about the tooling that you want to apply and the technology that you want to choose that suits your organization, but yet meet these principles. So in previous session, we kind of had a historical kind of overview of why data mesh and what are the assumptions it's trying to challenge, half a century assumptions. In this session, we're going to go into each of these principles that are foundational and core to building data mesh solutions, and talk about it and talk about the kind of a logical architecture that supports it. The very, very first principle is around the convergence of data and domain-driven design. So if you were in the last session, I introduced you the concept of the two modes of decoupling architecture, right? You can decouple your architectures to respond to scale, either based on technology solution or based on a technical task, or you can do it based on domains. So interestingly, in the operational world, right, in the business of like part of the business that runs the services and microservices and serve the customers, we have accepted and we have applied what Eric Evans called strategic design patterns in his seminal work on DDD, domain-driven design, back in 2003. So what I have here is a diagram from his book that talks about a set of patterns that you can apply when you're scale modeling. So he introduced two interesting concepts. One was bounded context and the other one context map. And he said, let's move to this multi-modeling world where the teams are modeling their world, their data, their systems, according to the bounded context, according to that domain, but they also recognize the relationship between these domains and create an explicit articulation of what these relationships are. Folks coming from the past session, you realize I used that kind of box in the middle to demonstrate the big data lake or big data warehouse, the monolithic solution. And the left-hand side are the domains that are more aligned to the source of the data, to point of origin. So and I use the digital media streaming because we probably have subscriptions with various ones like Spotify and so on. So it might, it might resonate with us. So the domain-oriented data ownership as a paradigm shift with data mesh articulates that we've got to change both our architecture and ownership of the data aligned with where the data comes from or where the data is used. So you might have a media player teams that are building the media players, for me to listen to music, but those teams today are not really responsible for media player events or historical view or daily journey of a listener, right? These are the information they have and they emit from their media player tools, but they don't really provide that as analytical data. And we define analytical data as aggregations around the subject, like players, like podcast listeners, like emerging artists, with a historical time variant view. So time scale always have to be there, because analysis of the data, you either are doing retrospectively, time traveling in the past, or making predictions with your machine learning, time traveling in the future. What this diagram shows as the foundation of data mesh is we need to move data ownership and architecture to where it belongs, to people who most intimately know about it. And then you end up with domains that are aligned with the source, where the data comes from, the domains that are aligned with the consumptions, like that emerging artist was an example. We say maybe the business, wants to create a new offering to their artists that are sharing, their content on their platform. And the way they do that is by recognizing who this emerging artist is, by correlating names of the artists on the social media with the trends of the listeners in a particular, perhaps, region, and providing that information to provide planning events. I mean, I'm just now getting creative here as how it can be used, but you can imagine, different scenarios. But we might say we will provide this emerging artist to the rest of the organization. Maybe they want to do, maybe the event organization that organize events for artists want to use this information for organizing events where the popular fans are. So then you would get this data sets that are more aligned with the use case. And then in the middle, you always end up with this kind of master data tradition known as master data, but aggregates of domains like subscribers. Information about subscribers come from many different domains. What does that look like architecturally? So the logical architecture around this domain-oriented data ownership is, if we use that bounded context, right, that domain boundary as a unit, that domain boundary in the past, if you see that like lollipop with an O down the bottom, in the past had its operational operational capabilities provided, right? You had a bunch of APIs that let you subscribe or unsubscribe. Now you would need another lollipop, which is the analytical data that you're providing to the rest of the organization. So it's the convergence of data and compute data and capability into one provided by the domain. So let's look at an example. Well, I have a bunch of domains here. Let's look at the podcast. Podcast domain operates a bunch of systems and services that allows you to create podcasts or release podcast episodes. But also now it's responsible to give you analytical information about podcast listeners' demographic. But to know about podcast listeners' demographic, it needs to get information from the user management domain, right? The one that keeps all the information perhaps about the user profiles. Perhaps it needs to get information internally from the podcast listeners to see where they're connecting from, what time of the day they're listening to, what location they're connecting from. So this transformation to domain-oriented data, while it might look fairly obvious, right? We've done this in microservices. It's just a natural extension of that to the world of data. In fact, challenges some of those really basic assumptions and metaphors, most importantly, the metaphors that we've created. So I've put a bunch of them here. We've got to change this metaphor of flowing data. So we've used the source of life itself, water, as a metaphor to describe data, right? Data flows from the source systems to a lake so that we can consume it. Soothing, wonderful metaphor, but there is a danger lurks beneath it. And that is the case that we assume the data must be flowing into some sort of a cleansing pipeline before it becomes useful. And it's done by somebody else down the stream, right? We talked about this in the previous session. So we need to think about data can be sourced and consumed and be useful right at the source of it. So moving from one canonical model to multiple models. This is gonna hurt a little bit. It'll be a little bit challenging to understand. But the source of truth, this ideal that we've been, this ever-moving, I guess, goalpost of finding this source of truth, one source of truth. The world doesn't work that way. World is messier. People copy data, people reshape data from one domain to another. I just got data from my listeners, users, profile, and she shaped it into podcast listeners' demographic. So that one source of truth is not relevant anymore in the modern data world. But the most relevant copy, the most trustworthy copy, that might be relevant. So data mesh introduces there's a whole lot of more details behind it, how to bring this to life. If you're interested, I'm running tutorials later in the year, in May, to really go deeper. But I want to just get you think and get you challenged to some of these assumptions that now domain-oriented decomposition of the data kind of surfaces. So in short, we want domain-oriented decentralized data ownership and architecture so that we can have an ecosystem that has an axis around which it can scale. And that axis is mirroring how you're scaling your business already, is mirroring your business functions essentially, right? And each of these nodes need to be delivering value independently, right? This first one, the distribution of the data and its technology around domains, causes a whole lot of questions probably already running in the back of your mind that we need to address. So the rest of the principles and the rest of techniques that I introduce in building data mesh is to address those challenges. And one of those challenges, the first question that I often get asked is, Well, how is this going to be better than siloing of this dark data that we have in our domains right now? I have my subscribers' information in the database of my subscriber management, service, but I can't get access to it. I can't make sense of it. It's not valuable to us. So then, how do we address that? And that's where product thinking and applying this idea of the data is a product comes to play. So Marty Kagan, about a long time ago, in his book called Inspired, he's a well-known figure in the world of data product management and product thinking, defined that every successful product has three common characteristics. So it has to be usable, it has to be valuable to business and to people, and it has to be feasible. Technically and business-wise, we have to be able to build it. So let's bring this idea of a successful product and map it to the world of data. So what does it look like? There's a lot going on in this diagram, but let's go one by one. First of all, we talked about domains, right? The artist domain, the podcast management domain, the subscription management domain. These domains now require to provide their data as a product to the users. The people you see on the right-hand side is this wonderful, diverse spectrum of data users that exist in organizations. They are the data analysts that like to maybe play with CSV files and sheets, or data scientists that they would like columnar files to build feature stores. They have very different modes of access. So what then that means, it inverts the model of serving data from a very technology-oriented to domain-oriented. It means that now the domains of artists or play events or whatever the domain is needs to provide the same data in different modes of access to satisfy the native tooling, the approach of accessing and fetching data that is native to a data scientist as well as is native to a data analyst, right? So that's where the technology needs to be kind of like, we need to a bit of a jiu-jitsu on the technology we have right now, because it just doesn't work right now. Right now, you put all of the data in a warehouse, give it to the analyst. You put all of data in a lake, give it to data science, and we need to kind of change that model. Serving data as a product to delight the experience of your customer doesn't come up with good intention. So we need to have people who are responsible for doing that. So the data mesh introduces new roles like data product owner, who has the responsibility of treating data as a product, is a long-standing owner of that data set. It does all of the good things that a good product managers do. It knows his or her customers. It knows the data intimately. It measures the success of its data, not based on how many data sets I have produced, those kind of vanity metrics that come from the past paradigm of treating data as an asset, not a product, but it measures how happy my customers are, how happy the data scientists are, how often they're going to reach to my data, what is the growth of adoption of this data within my organization. So there's a ton of good things that come to kind of we can adopt from the world of product management. But I want to talk about a few characteristics that are non-negotiable when you're building these data products. And the very first one comes from my favorite book, The Design of Everyday Things by Don Norman, the father of cognitive science, which talks about the most important characteristics of a good design of a product is discoverability and understanding. What is this thing about? What is my data about? Can I find it? If I'm looking for information about listeners, do I have a place to go and search and find the listeners and then find information about it? Do I understand it? So I think discoverability at each data product, I'm not talking about a centralized data catalog. That's a mechanics of implementing one, and is only one way of implementing. But each data product itself should be discoverable and should have all of the information that helps with that first step of a data user journey, which is what's out there. Let me discover what there is. Let me discover I can find what I'm looking for. The next step of a data product user is understanding, right? Okay, I found a bunch of data products about listeners and they have a relationship perhaps with each other, but can I understand it? So this is where you need a really well self-describing articulation of semantic of your data, the meaning of data. Oh, a listener, and semantic is really articulated by defining the entities, their attributes, and their relationship with each other. Listener is a subscriber. It can be a free subscriber or a paid subscriber, and it listens to podcasts from a location, from multiple media players. Like that's articulation of semantic. And then if you remember a few slides back, we said that data needs to be provided in multiple topologies, right? You might have columnar parquet files versus relational database, tables versus a graph. All of those modes of access to the same semantic might be possible, right? So then you have to say syntactically, I've encoded this topology in these tables with these primary, keys and foreign keys and things like that. The other characteristics on non-negotiable, it has to be built into every data product, that it has to be trustworthy. What does trust mean, and what does having a trustworthy data mean? I love this description of trust by Rachel Botsman. She's a trust fellow at Oxford University, and she wrote this wonderful, she has a few books, but this wonderful blog post, Trust Thinkers. And her definition of trust was a confident relationship with the unknown, right? In the case of data, I'm a data scientist. I found the listener's data set. I've read the semantic and syntax. I'm bridging that gap of uncomfortable, relationship with this unknown entity of my data product. But what else we need to put there to bridge the gap between that unknown to known? And that's where the whole set of meta information about the data needs to be available by each data product. How often this data product changes, how timely it is, what is the skew between the time that an event occurred, a listener listened to, and at the time that I actually published this information, how complete my data is, what is the statistical shape of this data, the volume of it, the mean and max and other statistical information, and optionally, and this is another controversial thought, optionally lineage. For years and years, we have had this overemphasis on this detective kind of investigation tool of lineage, that for me to be able to use this data, I must know where this data comes from and what transformation it has come through. The reason for that investigative mode of trusting a data was because you didn't actually trust in the process. You didn't trust that these data pipelines did their jobs and didn't lose the meaning and the syntax of the data along the way. So you want to go check for yourself. And data mesh changes that. Yes, lineage is important for debugging, for postmortem when things go wrong, but it shouldn't be the starting point. The starting point should be, I trust this data because the people who generated it in the first place own it, and there is an accountability that data product owners have. And there's a whole lot of SLOs that this data product guarantees, the same way we trust our APIs. So there's a whole bunch of other characteristics. I'm just going to jump over it for now, that really describes what being a data product means. And then looking at this architecture, again, the architecture changes. So if you remember that domain and that we had that O lollipop and D lollipop as the interfaces to the domain, now let's look inside. So I have an operational, the notation I've used is the box for operational system, microservice, and the hexagon data product. The idea is that this adjacent to your microservice of, let's say, managing subscribers, you have this data product, architectural quantum, that receives data on its input data ports from that operational systems, turn it into a long-standing, long retention, infinite retention of temporal data, and then provides it on this output port. So now I've introduced a new language in our vocabulary, IDP, input data ports, and output data ports, right? So let's see that in action. Remember that example about the podcast listeners demographic? So let's go inside. We have the podcast service, it's registering podcasts, it's relating podcasts. Maybe perhaps it's also keeping track of the played podcast, and the podcast listener demographic data product. It receives its data from that. It receives its data from the user profile updates, and then it provides in its output port the podcast listeners demographic. And it's really, you can see this mesh coming to exist, right? The mesh that now overlays those two planes of operational and the analytical data together. I introduced the concept of architectural quantum. So again, evolutionary architecture book by my colleagues, Rebecca Parsons and Neil Ford, Pat Kwa, introduced this concept as in the smallest units of your architecture that has all the structural components that it can do its job. So let's bring that to the data product. Data product, that humble hexagon, is our architectural quantum. And this is, again, it's a shift from the past paradigm of we just look at the data separately and then look at the pipeline separately. It says, let's bring it together. data and the code that processes and serves it and the infrastructure that runs it and serve and protect it, they all are one unit of architecture. Very similar to the progression of technology we saw in microservices with Service Mesh and Kubernetes to bring all of the cross-functional capabilities and the capabilities of the service as one quantum, one autonomous unit of deployment. Why doing all of that? So that we can still delight the experience of our customers while distributing the ownership of it, and we don't go back to that siloing. All right, this is the point of the conversation that CIO or CTO says, well, this sounds very expensive because every one of my teams now need to maintain this pipeline. And that's where platform thinking comes to play, right? We have done this in the past. I won't go through a lot of details here, but we've enabled autonomy through self-serve platforms. It's the same thing. Now we have to create this new set of teams, new set of infrastructure that allows the data product developer to say, I just wanted to, introduce that data demographics, the podcast demographics. Here are my input ports. That's where the data comes from. Here are output ports. This is how I want to encrypt it. This is how I want it to be secure. This is how I want to, apply the policies of access control. Infrastructure, go provision that for me, go manage that. I don't want to deal with that. What I want to deal with is only my transformation code, my business logic for bringing this data into the formats of an analytical view, right? It's a temporal view. So this team of data platform developers now need to satisfy the data product developers experience, right? They need to reduce friction for the data product developers. They need to make sure we can spin up new data products easy, like building a new container. And these are kind of domain agnostic capabilities that they have to build. So what are these capabilities? There are multiple planes, multiple layers to this, infrastructure. At the highest level, you want to have this self-serve platform with a bunch of interfaces, right? Interfaces might be command lines, might be APIs, might be a whole bunch of, Terraform templates. They provide the best data product developer experience. We've built this for our clients that you declaratively, our data product developers can just declare all the bits and pieces, all the structural components and the traits of their data products, and our platform provision it for them. They can read from the data, they can version it, they can secure it very easy. We also realize that there is an infrastructure plane that already exists, like for advanced data product developers that just want to get to they want to do the provisioning themselves, but they need a cloud storage or a storage account or some sort of orchestration, workspace. So you need to kind of have that low level infrastructure, but hopefully as your platform mature, you just work at this kind of mesh level operations and data product experience level operations. And then there's a bunch of capabilities that requires that mesh level operation, right? You still want to do queries that join data across different data products. So you need to have some sort of a federated query. You still want to explore this mesh and be kind of navigated. So these are the capabilities you need. So in summary, to be able, we need a self-serve data infrastructure that allows the data product developers autonomously without dealing with complexity, without overhead of extra cost of operation to build and maintain data products. And the last point, now that we've distributed everything, now that we rely on an automated infrastructure, what does the governance look like in this world? In this world, the governance has two properties. It's computational. It tries to enforce capabilities at the platform layer level at every data product. It embraces decentralization, and it's made for interoperability between these nodes, right? In the past, the governance has been around placing the system in a straitjacket, right? Define this canonical model, make sure it doesn't change, so we don't upset the users. And that is really challenging. That ends up as the ecologist Hollings says, ends up in fragility of the system. So the logical architecture that data mesh introduces is really requires a whole session for itself. But at a very high level, it's a federated model from those data product owners coming together and having a set of local and global incentives to make sure interoperability of their product with other data products, and local incentives, as we talked about, the growth of their own data product and business. And then defining these global policies, like How are we going to implement access control? How are we going to, implement schema management, or whatever these global concerns that need to be standardized, define that, and then push that to the platform to implement in an automated fashion. So these are just some of the examples, like standardizing data product semantic modeling, standardizing all the metadata, standardizing the interfaces to the data product, standardizing how we manage security. These are like a ton of concerns that go and get implemented by the platform and decided upon by a group of people that coming from those domains together. This is a departure from how we've done governance in the past, and it's a big deep leap from the past. So we're moving from a centralized, command and control or governance to a federated model. We're moving from a central team deciding what the data quality, responsible, actually not deciding, but responsible for the quality, responsible for security, responsible for compliance with regulatory, to a model that they're just responsible to define what is the method, what constitutes quality. Let's define quality together as a standardized way, but let's leave it to the platform through its integration tests, through its quality tests, through its automated pipelines to enforce those policies. So very automated, very computational. And the measure of success is not that, we've got that many golden certified data products. The measure of success is the value that those data products are producing through the network effect of connecting them to each other and creating new views. So that, in summary, we move from a centralized governance to a federated computational governance so that we can get value out of these independent data products, still at a mesh level, right? That emergent intelligence that by connecting these data products and by interoperability and composing them, we can create. So in summary, data mesh is not just an architecture, it's not just a technology, it's not just an organizational change, it's all of the above. It's a paradigm shift in how we manage big data between those two planes, right? The two planes that still exist, but now they're getting integrated around that kind of oval-shaped, colorful domains that I've drawn you. It requires a new set of technology to support the level of sophistication that this distributed data management requires. It requires a mind shift in how we manage and govern the data. So I'm excited to see you maybe next time and on a different occasion to go deeper into each of these pillars and perhaps look at some of the implementation we have done. Thank you for coming along with me and listening to this talk.
All right, that concludes our 2-day agenda. I want to thank you so much for joining us. You paid us with your attention, and we hope you had a chance to step back and think about your strategy while taking away tips you can action tomorrow. I'm going to turn it over to our CEO, Justin Borgman, to say a final few words, but thank you again.